here we're trying to find all possible rational zeros, so we're not saying which ones are answers, just out of rational numbers only, which ones could possibly be answers. So there's a theorem to go along with this, and how it works is you want to take all the factors of the last number over all the factors of the leading coefficient. So last number being the constant if you have it in decreasing order. And so for this problem, our last number is -3. So we need factors of -3 over factors of our leading coefficient, which is 7. So let's write down all the possible factors of 3. So we could do positive or -1. We could do positive or -3. Then we'll write down all the factors of 7. So it could be plus or minus 1, plus or minus 7. All right, if we want all the combinations of this, or all the possible combinations, so I could do 1 over 1. Notice it'll always be a positive or a negative choice, because positive 1 divided by positive 1 would be positive 1. We could do 1 plus 1 minus, 1 minus 1 plus. Either way, you end up with both these choices. So we could do 1 over 1. We could do 3 over 1. Then we could do 1 over 7. And we could do 3 over 7. And they also give you a direction. It didn't happen here, but to make sure that you don't list anything more than once. So sometimes you end up with something like, say there was a 2 over 2. That's the same as 1. So make sure you simplify all your fractions. If something's already on the list, you don't need to list it twice. So we have 1, 2, 3, 4, 5, 6, 7, 8 different possible rational zeros to this.